Welcome to Talkcast and to a spontaneous episode. I do have in the pipeline, so to speak, some episodes on the fabric of reality, in particular the next episode on quantum computation, part 2 of dealing with that chapter from the fabric of reality. It's taking a little more time than I first thought. I'm taking a deeper dive into quantum computation and some of the algorithms that come along, quantum algorithms that come along with quantum computation as well. So there's that. There's also the next chapter in Rationality, the book by Steven Pinker, which sometimes I think to myself should have been called Irrationality for some of the errors that are made. But of course, he's not all wrong when it comes to what counts as being reasonable, what counts as being rational. However, as we'll see in the theme today that I explore, there's a severe lack of contact with what I think is the deepest form of epistemology and rationality that we presently know. Anything that Popper wrote on the topic, essentially. But people are, I think, sometimes trying to deliberately avoid Popper. And I say deliberately for reasons that I will come to today, because I'm going to be exploring some choice tweets that have come across my feed over the last few weeks, some of which I haven't responded to because they've just seemed to be such egregious errors that I continue to stumble across day after day and week after week and month after month. But, misconception is everywhere, and so we should expect to find mistakes everywhere, and people are making mistakes all over the place. But should some people be a little more informed than others? I would think so, especially if they're speaking on an area that they claim some expertise in. Having said that, let me begin this episode by talking about a tweet by Michael Nielsen. Michael Nielsen is a great physicist, a renowned writer of textbooks on quantum computation. Well, the writer of possibly the most famous of all textbooks on quantum computation, one of the earliest ones on the field, sort of set the stage for learning in the field, really. He's written on technology broadly, on deep learning. He's written another textbook there as well. His website is a treasure trove of resources. But curiously, when it comes to philosophy and epistemology, I find Michael Nielsen to be extremely wide of the mark. And this is unusual. It is unusual in his particular case for reasons that I'll come to shortly. But I just want to mention and flag up front that I think that this is a peculiarity of theoretical physics, I find at times. It is the theoretical physicists who tend to dive deep into epistemology without knowing the first thing about it, but they think that because of what they do, their particular subject area, that gives them some special insight into how science more broadly and knowledge production works in general. But they seem to get it wrong. They get it wrong in their own field as well as more broadly. Now, how could they possibly get it wrong in their own field? Well, I have made this comparison before. The comparison is between the pilot and the aircraft engineer. On the one hand, the pilot knows something about how the engines work, but basically their job is to get you from A to B, to make the actual progress. They don't need to know how it is that they're achieving what they're achieving at times. Einstein did have roughly the right epistemology, but even if he didn't, he still could have made those same kind of discoveries. Now, I think in general, if a scientist has the right epistemology, they can make progress faster. They can correct their errors faster because they'll be a little more critical about what they're doing. But there's no necessary link here. There's no necessity for a scientist to understand the mechanics of the engine, if you like, of how knowledge production works. They can get along with doing the knowledge production in the same way that the pilot can fly the aircraft from point A to point B without really understanding the mechanics of how the engine works. On this metaphor that I'm torturing, it really is the case that the philosopher of science who knows what they're doing, they are like the engineer. They understand how it is that combustion and turbines actually work to produce thrust, to get the engine to push the aircraft through the air from one place to another, and to cause the wings to give it the lift that it needs. Now, of course, there are lots of philosophers out there that have entirely the wrong epistemology. They think that something like the engines provide levitation and anti-gravity force. Not really. There's something correct there, but they're not actually getting over gravity. Lift is not exactly anti-gravity. It's a different thing. Okay, there's a physical force there. The philosopher of science trained in Popperian epistemology, who has an understanding, let's say, they don't even need to be trained, but has an understanding of Popperian epistemology, is going to be the engineer that correctly grapples with how the thrust is produced via combustion through the turbine and the engine and all that sort of stuff that goes on with a really working engine in an actual aircraft. Sometimes there are these rare unicorn people like David Deutsch who are both pilot and engineer. They have expertise in both areas, but this is extremely rare. It's extremely rare for a single individual to both know how to fly the plane, to do the physics, and also have an understanding of epistemology, how the engine does what it does. But the overwhelming majority of physicists don't know philosophy, and perhaps they don't need to in order to get the thing done that they want to do. Except when they step outside of their own area and they start opining on how knowledge is produced. Then they begin to make clangers. And of course the reverse happens all the time as well. You know, we all know of the philosophers who are egregiously naive and ignorant of parts of science, even though they want to tell us about how science actually works. So where does Michael Nielsen come into this? Well, Michael Nielsen is extremely knowledgeable about physics. He's extremely proficient in being able to understand how quantum computation works and how deep learning works, and he has a good understanding of technology and the place at which physics finds itself right now, all this sort of stuff. But epistemology and philosophy of science, well, let's see. Here is a tweet from Michael Nielsen very recently that I held myself back from responding to. It says, quote, "Something I find peculiar. You take a great enormous mess of data, tides, projectiles, planets, sun, etc., and boil it down to simple, beautiful laws, Newton, and then gather even more data, perihelion effect, special relativity, etc., and boil it down to simple, beautiful laws, general relativity," end quote. And so here we have, in pristine form, a kind of defense of empiricism. The very thing that I spent a good 5 hours exploring and explaining in my series on the sources of knowledge and of ignorance, the lecture by Popper, that goes through detailing the history of empiricism from Bacon through to the time at which the lecture was delivered. And he explains his own epistemology and why it is that although empiricism was an advance on previous kinds of ways of deferring to authorities, it nonetheless replaced that kind of deference to authority, religious authorities and so on, with the authority of the senses, the authority of observations, the authority of data. Michael Nielsen is making the same mistake. So all the progress that Popper made, the advances that Popper made, have been ignored here. Now, is Michael Nielsen a special case? Isn't he just giving us this man on the streets take, the usual understanding? Yes, he is. Should he be more immune to this? Perhaps not. Perhaps physicists don't have a special privileged place with understanding how knowledge is produced. That's fine. But Michael Nielsen is a special case and a special physicist. Why? Because he claims throughout his Twitter feed to have read the entire works of Popper, or at least the major works. And he claims to think that Lakatos and Feyerabend, Popper's students and colleagues, have more interesting insights when it comes to the philosophy of science. And he also thinks that Thomas Kuhn had a better view of epistemology than Popper did. So, that would suggest that he has a deep understanding of Popper. Or does it? Well, apparently people can read Popper. They can read his evisceration of empiricism and yet still come away with ideas like this. Ideas that were refuted decades ago. Ideas that come to us from centuries ago and have long since been overthrown by actual epistemology. Epistemology that talks about how knowledge is conjectural. It comes from within, not from without. But this idea that Michael Nielsen gives us here in this particular tweet is the old classic idea that you take a great enormous mess of data, you observe the world and write down your findings, possibly numerically in some way, shape or form, in terms of tides, projectiles, planets. It's interesting how he then slips into more data being the perihelion effect, but also special relativity. How is special relativity a piece of data? Isn't that a substantive theory that Einstein came up with? And why did Einstein come up with this theory? Did Einstein merely collect lots of data, or was he solving specific problems, specific problems in electrodynamics, as it turns out, trying to figure out whether the force between charged particles at rest was different or the same when these charged particles were moving? Under the physics that was understood at the time, it should depend upon who you were, okay? Whether the observer was at rest or stationary, the force would vary. And this is why he had to bring in this idea of special relativity, where you had a constant speed of light, which affected things, which under Galilean relativity, you didn't have a constant speed of light. In fact, you didn't have an upper limit on velocity at all. You go as fast as you like. But under special relativity, the actual laws governing motion, you do have this speed limit set in the universe. Now, I didn't respond to this. I didn't go down the road of talking about how, in fact, what we do is conjecture. We conjecture our ideas, our theories about the world from within, and then test them against the reality outside. This is a different vision about what's going on. It is the idea coming from within, tested without, rather than the idea out there, somehow, in reality, being derived by us from raw data in some way, shape, or form. Now, this cannot work for the reasons that I have spent many hours going over. And although I was tempted in responding, I didn't need to, because happily David Deutsch did respond. And what did David say in response to Michael Nielsen about this? David said, quote, "Yeah, none of that ever happened. It's a post hoc misinterpretation caused by the common sense appeal of empiricism, which systematically neglects the role of theoretical problems." End quote. Now, this is all very true. It is an appeal to the common sense of empiricism. Empiricism is the common sense idea that you look out into the world, you observe it, and from your observations you derive the knowledge. This is completely false. Now, again, Michael Nielsen, should he have any special immunity to this? Not necessarily, except he claims to have read Popper and Lakatos and Feyerabend and the famous philosophers of science, and moreover, is writing a book about what he idiosyncratically calls meta-science, which I would just say is another term for the philosophy of science. But he is, as I said, beginning this video today, it seems to be a deliberate attempt to ignore Popper. And I don't understand this phenomena that we have in the intellectual world, in academia. They are allergic to this straightforward understanding of epistemology. And in speaking to people about this, it's hard to really figure out precisely, to put your finger on what it is about Popper's work that really makes people allergic to it. Perhaps they just don't understand it. And David Deutsch has said, not specifically on this question, but on other questions when it comes to this kind of thing, is that people tend to read what they expect to read in a particular text. So you come to the text, you come to a book, you come to an article with a theory about what you're going to read, and insofar as the theory that you have about what you're going to read conforms with what you read, it then isn't refuted, then you just accept it. And insofar as it does refute what you're saying, you just ignore those bits and you continue to read through it. That's one phenomenon. Another is, as I've mentioned before, and I was, and to drop a name here, I was texting with Naval about this, messaging Naval, and he was saying, well, the fact is that Popper was a great critic of the intellectual community. He was a critic of academia as it exists, of industrialized type science. And so therefore, of course, he's not going to be popular. And I've thought this myself over time as well. If you spend your time criticizing academia, criticizing philosophy and your peers, and criticizing the way in which sometimes science is done, then of course you're not going to be popular amongst the intellectuals of any era, because you're criticizing intellectualism. It's similar to the way in which Ayn Rand is so quickly dismissed by university academics. It's in the same vein. They both share the characteristic of criticizing the very people working as experts in that particular subject area, namely philosophy. And so, of course, they're not popular amongst philosophers. And by extension, if they're not taken seriously by other philosophers, they're not going to be taken seriously by scientists who come to philosophy perhaps late in their career, or at some point in their career decide to make a little shift into philosophy. But in speaking to philosophers or reading other philosophers, realize that, well, this Popper fellow or this Ayn Rand woman, they're not being taken seriously by other academics today. They're quickly dismissed. And so therefore I, as a scientist, wanting to be taken seriously now, not only in science but also in philosophy, I too had better disregard what these people have said. That could be one of the phenomena that's going on. Okay, so let's see what else David had to say here about this. David goes on to say, after he's just said that none of that never happened, okay, so namely that People don't, you don't take an enormous mess of data and distill out the laws of physics from the data. That's not what happens. You conjecture the laws of physics, then you check against some data that you collect. What Einstein was doing with general relativity was solving particular problems. That's what's going on. He's not deriving the laws of general relativity from observations. He can't see the curvature of space-time. What he's doing is solving particular problems. David goes on to say, he gives an example, for example, despite what he said about writing on photons, I don't think Einstein arrived at special relativity by contemplating Michelson and Morley's observations. He did it by contemplating the conflict between Maxwell's equations and Galilean relativity, end quote. Maxwell's equations, these are the equations governing electromagnetism, both electricity and magnetism, and there were problems trying to fit this particular theory about the laws of physics and moving charges in particular, whether you were moving with the charges or the charges were seen to be moving relative to you. There's a problem with that, with how the laws predicted what was going to happen, the outcome of the particular experiments in those particular cases, and Galilean relativity being non-special relativity, where in Galilean relativity, it's the common sense view that when you have relative motion, I'm heading along the highway at 60 miles per hour south and you're heading 60 miles per hour north, and the relative velocity between us is 120 miles per hour under Galilean relativity. That's common sense. It's common sense and false, okay? When you actually do the mathematics according to special relativity, it's slightly different to that, and this is because one of the reasons is, well, the way in which you calculate relative velocity under special relativity comes out different because the speed of light is a factor. There is an upper limit on how fast you can go according to special relativity, and in reality you test this, but there is no such finite limit. There is no limit on how fast you can go under Galilean relativity. On special relativity, the speed of light is constant. Under Galilean relativity, the speed of light depends upon how fast the observer is going. But of course, that's false. We can test that. We can distinguish between these cases. Okay, so that's Michael Nielsen. Let's leave that behind. He's just one example among many physicists who, especially online on social media, like to opine as much on philosophy and epistemology as they do on physics. And I don't mind. People have their ideas, and this is all great. It's just that almost none are Popperian. Almost none understand actual epistemology. Almost none are familiar with the works of Karl Popper or with David Deutsch. And insofar as they say they are, they display by every word they speak on the topic or tweet on the topic or write on the topic that they don't know the first thing about how knowledge is actually constructed. They are allergic to the notion of conjectural knowledge. And of course, when it comes to Popper, they dismiss him as that guy that thinks that every single theory that we have needs to be, as a practical matter, testable right now. You know, that he's a naive falsificationist, that kind of thing. And then they write long essays, as Sean Carroll has done, for example. Great physicist, no doubt. But when it comes to epistemology, writes things about how we need to do away with ideas like falsifiability because Karl Popper was too naive and this isn't how science actually works, and so on and so forth. But it's always couched in terms of theoretical physics. It's always narrowly focused on theoretical physics. The same as Michael Nielsen's concern there about how exactly knowledge is created, derived from the data. It's not applicable to biology. It's not like Darwin was collecting data and deriving natural selection from that. No, he was solving a problem about the diversity of species and the origin of species. That's what he was looking at. He was looking at this problem and testing to see whether or not the observations could be explained by this theory. A geologist interested in exactly how it is that you have these different kinds of rocks and what metamorphic rocks are, and how you have these pre-existing sedimentary rocks and igneous rocks, and these can be transformed over time under the action of heat and pressure over millions, hundreds of millions, billions of years into these metamorphic rocks. This is an explanatory framework where you're not collecting data. You're not writing down lots and lots of stuff and extracting out of that data the idea or the explanation of metamorphosis when it comes to rocks and rock chemistry and rock geology. It is only the theoretical physicists that get this catastrophically wrong and are extremely confident that they know what they're talking about, and they are going to pass on their deep wisdom about how knowledge is generated because they think that their misconception about how it works in theoretical physics applies broadly to all of science. They don't tend to consider the rest of science. When they come up with their examples, it always is at the very boundary of what we understand. They're highly mathematical, theoretical ideas that we have. And it's plausible in that area, because you've got numbers and you can talk about extracting formulae from numbers, that kind of thing. And so you can give a plausible account of what instrumentalism is and how what you're really doing is predicting stuff. Of course, this only applies to the special case of particular physical sciences where you're actually interested in trying to predict the outcome of experiments at times. But this is not what science is about broadly, and the message about what science is about broadly, namely explaining the world, the phenomena in the actual universe, in terms of what really exists, giving an account of what really exists. This applies to all sciences, including theoretical physics, where prediction is not the main point. Prediction is just a fortunate thing that you can do in physics, a very fortunate thing you can do. And it's important, no doubt it's important, but it's not the aim, and it in fact is not the reason why the science exists. And we shouldn't expect physicists in general to be great philosophers, as I've already implied here, but they do love, it seems, more than any other scientist, to opine on the intricate details of epistemology at times, as much as they like to opine on physics, where they spend most of their time learning and training the actual physics, and they have robust, resilient knowledge. When it comes to epistemology, they think they can just dive in, that they've already managed to somehow absorb by osmosis the way in which knowledge is created without really carefully thinking about it. And because they don't carefully think about it, and by that I mean really connect with people who've made advances on this before, it's like they're working, it's like they get upset. The theoretical physicists and the physicists in general are the first people to get upset with receiving emails or reading blog posts about how some engineer has used an algebraic method to disprove Einstein's theory of relativity. Okay? And so this is what physicists all agree on, and they all get together and they laugh about how these silly engineers, these retired engineers, so goes the joke, have disproved Einstein. Okay, and it is silly, and I can imagine that it can be frustrating for physicists to receive email after email from people who think that they've discovered the theory of the universe, and they want some high-profile physicist to read their paper. And if only you would read my paper and read my theory about how to unify quantum theory and relativity and how we can overturn Einstein, here's my algebraic method for doing so. If only you would read this, you would realize that you've been spending your life doing the wrong thing. And the physicists laugh about this. Okay. The same feeling of this is an embarrassing, sort of unedifying sign of ignorance and naivety on the part of this person. It's highly unlikely they're correct, and of course, every physicist knows the feeling of reading through something like this and getting to the end of it and realizing, well, you've just made clangor after clangor there. You can't disprove Einstein with a simple algebraic argument, and what you need is a testable theory and all this sort of stuff. The same feeling comes to the Popperian when they read stuff from certain physicists who, if they've read Popper, they haven't understood him. But in general, they haven't read Popper at all. And it just comes off as super naive. It comes off as the retired engineer trying to disprove Einstein. And on that topic, okay, we shouldn't be surprised that people are ignorant of stuff. And it is no sin to be ignorant. It's just that there is this double standard out there, I think, in physics, where the physicists will accuse people who aren't trained in physics of not being sufficiently knowledgeable about physics, and so therefore unentitled to have a proper opinion on physics. Shouldn't have an opinion on whether or not string theory is correct or not, because they don't have the expertise in that area. But when it comes to epistemology, all bets are off then. Anyone can have an opinion. I think anyone can have an opinion, but it would just be refreshing if people would sometimes make contact with Popper. So moving on that same theme of ignorance about this sort of stuff, Professor Brian Keating, who I don't really know, I admit I don't know him, but well, let's just read. He has written here, quote, Feynman, and he's quoting Feynman, "Science is the belief in the ignorance of experts." And then he goes on to say, Professor Brian Keating himself, "Truth is, all scientists are ignorant at some level. Some are more ignorant than others. Science is the worst form of epistemology, except for all the rest." End quote. Well, yes, all scientists are ignorant at some level. How about all scientists, like all people, are infinitely ignorant? There's, on any topic that we do know about, any topic whatsoever, that topic we can be infinitely ignorant about, and we're infinitely ignorant about everything else as well. Some are more ignorant than others, while some are more knowledgeable and have more speciality in certain areas than others. But again, we're all equal in our infinite ignorance, as Popper would say. So, this idea that it's trying to set up a hierarchy. Some physicists are good and some physicists are not so good. And, okay, some physicists know more than others. Big deal. I think the emphasis is in the wrong place. Rather than trying to have this hierarchy of people where some know more than others, as Popper would say, while differing in these little bits and pieces that we do know, we are all equal in infinite ignorance. It's better to just concentrate on the fact that we've all got an infinite amount to know. And so we need to be humble in the way people, of course, now might be screaming at the screen saying, well, you, Brett Hall, you're not being very humble. You're having a go at these, prominent physicists, who know what they're talking about. They do physics. But, it is clear that these people don't necessarily know what they're talking about. Like the very next line, science is the worst form of epistemology except for all the rest. End quote. Science is not a form of epistemology. Science is a subject area. Epistemology is a separate subject area. Science deals with theories about the physical world. Epistemology deals with how it is that knowledge is created. These are two separate domains. Science doesn't tell you how the knowledge in science is created. Science is that very thing trying to figure out how the world works, the physical world. When it comes to knowledge, that's the domain of epistemology, and that is what Popper was an expert in. Popper was an epistemologist of the first order, and he explained how it is that we conjecture ideas and then we attempt to refute those ideas. And insofar as they survive attempts at refutation, and they, in David Deutsch's terminology, are hard to very good explanations of the world, then we accept them as part of our corpus of knowledge. But even if they go and become refuted, they can still remain knowledge. And all this sort of stuff, viewers and listeners to Talkcast will know this. And I'm just emphasizing here that, again, it is a peculiarity, I find, of physicists, of theoretical physicists in particular, but all kinds of physicists who are extremely confident in demonstrating their complete ignorance when it comes to the field of epistemology and the philosophy of science. And, I have remained rather polite in the face of reading over and over again the physicists' proclamations about how knowledge is produced. And they always give us the same kind of stuff. They always give us the same old empiricism, without ever grappling with how knowledge is genuinely being created, how knowledge is actually created. Okay, so sometimes they're Bayesian in the way that they look at things, but it still comes down to you're observing stuff and you're extracting knowledge from the observations in some way. You're deriving it from the observations, rather than the observations serving the purpose of deciding between the theories you've already guessed. That's it. Or as being the explicandum, the thing that you are explaining. You're explaining the observations. The explanation is coming from within you, and you are imposing that explanation upon reality. You're not drawing it out of reality. It's not out there in reality. After all, if it was, going back to Michael Nielsen's thing, if we're extracting the knowledge from the data, then why does the data contradict itself? On the one hand, it says, well, Newtonian mechanics is the explanation of this data, but the same data from the same reality, effectively the same data, okay, a little bit more data, completely contradicts what is being said in that first case. In other words, we have special relativity, we have general relativity. On the one hand, we say, well, gravity is a force that travels instantly between bodies. And on the other, no, gravity is not a force, the curvature of space-time, and at most it can travel at the speed of light. On the one hand, we say there is no upper limit on how fast objects can travel through space. And on the other, we can say, well, no, the speed of light is a universal limit throughout the universe. These things conflict with each other, and we're not drawing those facts, we're not deriving those facts from reality, we are conjecturing them from within and then testing them against that reality. And because we know that our conjectures, our guesses can be flawed and should be flawed and will be incomplete, that there will always be a gap between what actual reality is and what our knowledge of reality is, we should expect the theories that we have to sometimes conflict because they won't be the complete picture. They will always be errors within them. There will be uncertainty. We are fallible, and so therefore our theories will be incomplete because they cannot be perfect representations of reality. Reality contains no contradictions, but our knowledge of reality will absolutely contain contradictions. And that is one of the problems that we want to solve as we make progress, and it's the way in which we can make progress. But you won't be able to account for any of this if you're an empiricist, if you're a Bayesian. It won't make sense to you. Only under Popperian epistemology, where we have a source of ignorance as well as the source of knowledge coming from within us, as explained again in that 5-hour series that I did, will you be able to account for both the error within your knowledge and the truth within your knowledge? Both of these come together in lockstep. And the more you learn, going all the way back to Socrates, the more that you come to understand, the more is revealed to you about what you don't understand. Your ignorance actually increases. Your knowledge of your ignorance increases as you learn more. And this is the fact that it sounds like a contradiction, but it's not. Okay, that'll do on physics and physicists and that kind of epistemology for now. Let's move on to a couple more interesting tweets that, again, came across my feed recently. One was from Orson Lake, who tagged me by saying, I can imagine both David Deutsch Oxford and Talk Teacher commending this view. And this view was by a fellow called Gregory Hansel. And Gregory Hansel said, quote, "Liberty, democracy and free speech are conditions that allow for human flourishing even more than techno-capital. They facilitate the proliferation of human life and ideas," end quote. Yes, absolutely. I mean, you could have lots and lots of capital, lots and lots of money invested in technology in a place like China, and yet use it to actively suppress liberty, democracy and free speech. Liberty, democracy and free speech, I would add, are special cases of something deeper. Special cases of what David Deutsch has told us in his work on optimism, a culture of criticism. A culture of criticism, or tradition of criticism, a tradition of criticism is this thing that stands against all other kinds of traditions that hitherto have existed on planet Earth. Traditions were ways of keeping things the same, but a tradition of criticism is a way of ensuring that you have progress or change which is stable over time. Stable because it's a tradition, but because it's a tradition of criticism, the criticism has the effect of distinguishing between good and bad ideas, and ideas that allow for progress and ideas that stunt progress. And if you have this panopticon view of criticism, you apply criticism applied to everything, then you'll have improvements everywhere and you will have liberty, democracy and free speech. These are just special cases of this deep phenomena known as the tradition of criticism, which is part of the Enlightenment. And at their best, this is what Western nations allow. Now, it would be my opinion that over the last few years, we have had a problem with the tradition of criticism. And some of the traditions that hitherto, mind you, we have defended, robustly defended, have come under attack. And so there has been certain kinds of clampdowns on free speech, certain kinds of clampdowns on liberty, and even democracy. There's been anti-democratic turns. Now, are these existential threats to democratic Western nations in the Enlightenment tradition? No, I don't think these are existential threats, but they are threats nonetheless, and they're annoyances more than anything else. In some places, they are far worse than others. You look at a place like New Zealand, where you really do have a clampdown on free speech and liberty, and then you compare it to southern states of the United States, and you don't, okay? And then there's everywhere in between those. But broadly speaking, none of our countries are anything like China, okay? Despite what certain people, let's say on the conservative right, might have you believe, it's not that bad yet. But I think we need to defend liberty and democracy and free speech whenever it gets threatened. Whenever anyone is out there criticizing a tradition of criticism, criticizing a means of criticism, then we should criticize that. We should criticize any attempt to say that free speech is somehow violence. Okay, this is the trope that keeps being wheeled out over recent times. Or even if they say that these people support democracy, if they try and enact certain anti-democratic measures where you can have, for example, unelected officials making decisions, and those officials cannot be removed by any vote, and are resistant to being removed, that tend to have more power than elected politicians, this is a problem. Especially when we get into supranational organizations like the World Economic Forum and the United Nations, that kind of thing, where the people there are unelected. And yet, well, to some extent, they're unelected by the people over whom they are ruling, broadly speaking. And so this is where we have the undemocratic idea, where even if you have ostensibly some sort of voting system, but what really goes on, what really tends to happen is that the people who are subject to the rules cannot remove the rulers, the people making the rules. And this is certainly seems to be the case with the World Economic Forum, where these supranational organizations are telling democratic nations what they can and can't do. And the democratic nations, the politicians, are signing on to certain agreements where it's very difficult to get out of these agreements. Real problem, real problem. Yeah, the EU is a similar sort of idea to this. Won't go down that road right now. So yes, anyway, I do commend that view. Liberty, democracy and free speech are the conditions that allow for human flourishing, but there's something deeper still. It is the tradition of criticism that really allows for human flourishing. And this idea of techno-capital, certainly wealth is very, very important. But again, wealth is derivative of all that other stuff. It is the thing that comes later, which then you are able to use to make your tradition of criticism even more robust. But it is a consequence of the tradition of criticism. The most rapid wealth creation is due to capitalism, and capitalism is, and free trade, a specific species of the tradition of criticism as applied to trade, as applied to transactions between individuals in particular. Moving on, and an interesting one from Tadas is his handle. And he has asked the question, I think just broadly to a number of people, how do we quantify or know the amount of knowledge creation? Okay, and my opinion on this, in answer to his question, was that there's no known unit of knowledge. I said that one must use proxies, information processing, in, let's say, terms of floating point operations per second, which is, flops, might give some indication, but it's only rough. There is also, I suggest, a difference in quality between different kinds of knowledge, which is harder to track. End quote, quoting myself. So what I mean by that is sometimes people talk about this. They want to know how fast it is that we are creating knowledge and can we measure it and all this sort of stuff. Well, we don't have a unit of knowledge. And so because we don't have a unit of knowledge, what would we call it? The popper. Or the Carl or something like that. At the moment, that's the rate of, 2 Carls per second of knowledge creation or something like that. Okay, making a joke, but there's a point here. You can't measure something unless you've got a unit of it. And then once you say you're going to measure it, you need a measuring device and all that sort of stuff. So to quantify this thing is a bit difficult. But let's say you could. Isn't there a difference between deep foundational knowledge and just more derivative knowledge? So, something like Darwin's theory of natural selection, that contains deep, deep knowledge. And it's deeper, and in a sense, it's a higher quality kind of knowledge compared to something like, a biologist who would also be interested in, evolution by natural selection, who happens to be an ornithologist working in the Amazon rainforest, and he's, discovered 3 different species of toucan. Okay, so that bit of knowledge, the 3 different species of toucan, well, how much knowledge is that? What does that count as compared to the deep knowledge about evolution by natural selection? Well, the evolution by natural selection knowledge is a deep foundational theory. The new 3 species of toucan is a very derivative, high-level thing that, doesn't really touch other areas of science and philosophy and so on and so forth, in the same way that evolution by natural selection does. So I don't think we can quantify the amount of knowledge creation. All we can do is have proxies about how fast we're making progress at any particular time, given a particular technological metric or something like that. You could say, how many books are being published each year. Maybe that would give you an idea, but not really. How many YouTube videos are being uploaded, but a lot of them are entertainment. They're not really producing knowledge. All these sorts of things. So this is why I say, if you're looking at something in particular like, clock speeds of processors, amount of memory in a laptop, something like that would be a proxy for how much progress we're making, which is a proxy itself for the amount of knowledge creation that's going on. So that would be my answer to that. We can't quantify knowledge, but we can quantify certain proxies which are related to knowledge creation. Might just mention one that came across my feed as well by me. This is from the Tok Physics bot that randomly generates tweets based upon things I or Naval or David Deutsch have said or written at some point or other. And anyway, it's quoted me, and the quote is this, quote, "There are 2 equally important ways to be in the world when it comes to the process of knowledge creation. You can be a creator and you can be a critic," end quote. Yes, and it's important for me to emphasize this, that, I've written and spoken a lot about creativity and criticism. the two pillars of knowledge creation. And in this sense, creativity is just creating something without knowing whether or not it's going to be a genuine improvement. When it's a genuine improvement, we use words like innovation, something like that. So it actively improves on something that has gone before. Sometimes your creativity can be worse than the existing ideas. So this is why you need criticism. But criticism itself is a creative act. So really, there is only creativity. There's only creativity. And one species of creativity is known as criticism. But you have to be creative to come up with a criticism. But if you're teaching, schools are obsessed by this and universities are obsessed by this right now, the idea of critical and creative thinking. And I don't think that you can really facilitate creative thinking. You can't enhance it very easily. We don't know enough about it except to give people freedom and perhaps provide some constraints on what they want to do. So saying to a child, do whatever you want, okay, that's maximum creativity, maximum scope for creativity. But sometimes it's helpful to actually say, okay, do whatever you want, but make sure it's a poem. That can help, okay? Well, now we're focused on something. Do whatever you want, but make sure it's a poem and it consists of 7 lines and it's about trees. Okay, well now, you're helping the child actually to be creative, to try and guide them, especially if they say they don't know what they want to do. You provide some rails within which they can more actively explore the area, because if the space is infinite, it's very difficult to constrain your own thoughts at times. And then the maximum space to explore sometimes isn't the thing that allows you to actually achieve something, because you are paralyzed by too many options. Now, so that's one issue. So it's difficult to train someone to be more creative. You just have to give them the space to be creative, but the space need not be infinite. Criticism, I think, is something that can be more readily learned by learning about the process of epistemology, by learning about aspects of philosophy and learning about techniques of refutation. This is what background knowledge is. Background knowledge consists of the stuff that humanity has figured out, the stuff that solves a problem already, and can be used to criticize any new idea that you have. Not to try and prevent you from being creative, but so that you don't, going back to my first, couple of tweets that I was criticizing there, so that you don't make clangers, you don't make the same mistakes that have already been made before. You can build on actual knowledge rather than recapitulating from the ground up stuff that people already know. Far better to stand upon the shoulders of giants, see further and solve more problems than solving the same problem that Einstein solved. Okay, if you're learning, that's fine. Okay, solving the same problem that people prior to Popper tried to solve. Okay, coming up with Bacon's idea of epistemology, to return to that, is not solving any new problem. It's achieving nothing more than what Francis Bacon did back in the 1600s or the 1700s, whenever he was around. So far better to move forward. Okay, and so the way to do this is to be a good critic, to learn to be a good critic, and that involves having a significant amount of background knowledge. Okay, and the more the better, and to learn techniques whereby you can criticize your own ideas as well. Not only in light of background knowledge, but having heuristics. Okay, is the thing logical? Is it experimentally testable? How would you go about experimentally testing it? Is there a mathematical way of refuting this? And so on and so forth, all that sort of stuff. Are there logical fallacies in the argument that you're making? All this sort of stuff can be learned. It's not to say it needs to be learned off by heart, but certainly the more that you know about this kind of thing, the clearer a thinker you might be. Everyone is plagued by misconceptions, but it is excruciatingly obvious to everyone that someone like David Deutsch is a clear and perceptive thinker. Now, why? He has heuristics, many of which will be implicit, but he has deep knowledge about these things. It can be learned. But it takes effort. It takes attention, and it takes a willingness to understand the people that have gone before and who have made some progress, of reading the right kind of stuff. What is the right kind of stuff? Again, Popper would come to mind. Einstein, Feynman, Rand, all of these guys that are out there, and girls, all of these people that are out there that have actually made progress and in some way are standing in opposition to the multitudinous ways in which academia and the intellectual culture at the moment believes things, okay, what they think about knowledge and so on and so forth. It's not to say they're all wrong and completely wrong in all ways, but if you want to make progress, Agreeing with everyone around you is probably not the way to do that, because everyone around you will be doing the same thing as you then. You want to be doing something slightly different. And I'm quoting myself again here just to explore this. It's a little embarrassing. I should have picked a few more tweets. But let's just go with this. He has no shame. So what I've said here, and quoting myself, a prediction made in the absence of a good explanation is a prophecy. End quote from Talk Teacher. So, yes, I've said that. Now, I should explain that a little bit more. Now, that's a nice little aphorism. To be precise, a prophecy is a guess about the future where you are assuming you know what the growth of knowledge is going to entail. So, you don't know the growth of knowledge. You don't know what knowledge is going to be created tomorrow. So, if you try and presume that you do, you're making a prophecy. If you're presuming that human choice cannot possibly intervene, that there can be no explanation, which will cause people to choose something which will affect the outcome of your prediction, you're making a prophecy. Okay, so the classic example that we go to is, of course, astrophysics, in 7 billion years, so the astrophysicists calculate, that is when the sun will finally run out of hydrogen fuel, and the core will be left with helium, at which point the sun will collapse because no new heat is being produced in the core of the sun. The whole thing will collapse, falling in onto the very hot core, at which point the core will heat up because all of this infalling matter is causing compression of that fluid, of that gas. The temperature rises and you get what is known as the triple alpha reaction, the helium flash, and the helium then begins to convert itself into carbon. And that reaction, the reaction of 3 helium nuclei to produce 1 carbon nuclei, occurs at a much higher temperature than the previous reaction, which was hydrogen being converted into helium, that fusion reaction. And so because the helium reaction being converted into carbon occurs at such a much higher temperature, 10 times the temperature or something like that, the sun expands out to become a red giant. And this is what will happen in 7 billion years. Or will it? Because if people are still here on the Earth orbiting the sun, they might decide to do something about that, to stop it. They might have decided to do something long before that to prevent it from happening, taking mass away from the sun. Who knows what they might do at that point if they want to keep the sun burning for longer, let's say. Or maybe it will burn even shorter than that because they will decide to take some of the material away from the sun to do other stuff with it. Who knows what will happen? You can't guess what people will do billions of years from now with the knowledge they will have, how powerful they will be, how wealthy they will be, what they will be able to do with stars. Guessing what they will do billions of years from now is prophecy, not prediction. And therefore, trying to guess what will happen to the sun billions of years hence is also prophecy. The only way to get around this, to be scientific, is to say, assuming no human intervenes, assuming that no knowledge can possibly affect this, assuming that people do not become involved in how the sun evolves over time, then, and only then, we predict that in the absence of all knowledge creation, in the absence of all people doing anything whatsoever, then the sun will expand into a red giant in approximately 7 billion years. Okay, then that's fine. You've caveated it all in terms of error and uncertainty, which is the scientific thing to do. But as David Deutsch has said in the beginning of Infinity, words to the effect of, a result quoted without uncertainty is meaningless in science. And so this would include something like a prediction such as, or a measurement such as, the sun will last for 7 billion years more. Okay, I think I've talked for enough today. It's kind of a short, sweet one today, me talking fast at the camera and perhaps being a little bit lacking in generosity for some of the subjects and a little bit unashamedly quoting myself here. That will do for now. And, in the promise that within a couple of weeks, I'll have the next chapter of The Fabric of Reality out. But until then, bye-bye.